Welcome back to the Mob Mentality Show. I'm Austin Chadwick, and my co-host is Chris Lucian. And today we are very excited to have David Bishop with us, and he's going to be talking to us about mobbing with embedded systems, Agile with embedded systems, and let me get the name right, Agile Framework. So yeah, I got some great topics lined up. We're real excited about it. So to get us started, David, can you tell us a little bit about yourself?
Well, I'm an entrepreneur, developer, programmer, and technologist and researcher and inventor, among other things. I've worked in the technology industry for about 25 years, mostly in telecommunications and transportation and power utilities. And over the last 10 years, I've been studying Agile transformations a little more closely, trying to figure out what makes transformations successful and what makes them not so successful. And also, you know, how can we leverage agility to get the most out of it? How, you know, Agile can do a lot of great things. It can make it easier to work with teams, and it can improve productivity and quality, not that sort of thing. But the main impetus of agility is competition. How can it help you become number one in your market? And so that's the question I was trying to ask myself over the past 10 years. And I created a body of research on that topic, which has resulted in the book that we'll talk about today. But that's been my passion over the past few years.
Right on. Very cool.
So you worked with, so you know, we're kind of podcast around mob programming. And so I guess what's your experience with mob programming? And I think it's around embedded systems. And so I think our audience would love to hear about that.
Right, absolutely. So, you know, when I started looking at Agile transformations, one of the biggest issues that Agile transformations had, it was mostly geared towards software. And today it's really not about software anymore. It's more about devices. And devices are what? Embedded systems. Embedded systems is where you have software, firmware, and hardware often developed on different tracks by different teams, but it has to be released at some point as one cohesive product. That's very hard to do in an Agile way. And some of our most successful case studies managed to become number one in the market by leveraging agility in that situation, but very few of them did. But what I've tried to do is try and figure out what were those companies doing right. And there were a number of characteristics that we could go into, but one of those was pair programming and mob programming. I think pair programming being more of an earlier or a subset of mob programming. But I think that's very critical to agility within an embedded systems context, because you have to, not only do you have to have communication within the software development team itself, but you've also got firmware teams, you've got hardware teams that are working within themselves, but also they all need to come together at some point. And mob programming can be a great tool for making that happen. And that was something that some of our best case studies used to affect a successful Agile transformation.
Nice. So I guess, do you have more detail on that? What caused them to start mobbing? What benefits did they see out of it? Those would be both really interesting questions to ask.
Well, I think probably the impetus of it was so many dependencies and interdependencies. You know, when you look at a typical embedded systems product, whether it's like a smart thermostat or a smartphone or an IoT device, you've got software, you have firmware, and you have hardware. And the software teams are often waiting on test products from the firmware team so they can do their work, so they can build it into their test harness or their test bed and work against. Then you've got the firmware teams who are waiting on the hardware teams. You know, they may need a new chip or they may need a new device that they can use to develop and test against. And of course, there's this very complex interplay of dependencies and interdependencies between these development tracks. And how do you manage that? That was a big problem. These successful case studies developed a way to manage it from a project management perspective through reporting and Scrum of Scrums and things like that, which I go into in the book. But at the lower levels, not the lower levels necessarily, but the development and test level, there was a need to have a greater level of communication and interactivity to make these products happen. And so mob programming took a form of okay, we have some mob programming sessions within the software teams or within the firmware teams, but at some point we need to have a mob programming session with all three tracks involved, maybe once a week or something like that, to solve these problems of, hey, I'm waiting on you, you're waiting on me, or, how are we going to make this work together? All these interdependencies and dependencies that were constantly holding up productivity had to be resolved. And mob programming was one of the best ways to resolve those blockers.
Yeah, that's a fascinating story. So the idea of getting all of the dependencies in the same mob in order to kind of increase the flow efficiency or removing blocks when you're talking about maybe lean value streams or something, right? I think that's been a pretty common theme for us as we do interviews, is that a lot of the dependencies or just where people are waiting for other people and the responses aren't as fast as, basically when you're sitting next to them or you're on a call with them and you just say it back and forth while the programming is being done, you get it all out of the way. So that's really fascinating to hear. So was there resistance to these types of things? I know, like, I've heard of pair programming being really difficult to implement in different environments. And so I guess from what you had seen, how did they cross the divide of basically saying, hey, let's all get to work together, or was there one? What was the culture like, and how did it affect this transition?
Well, I think it worked better than pair programming. Of course, and pair programming can be very effective, but in many cases, that issue came up with pair programming, in that because it typically is two people, it sometimes takes on the wrong context of mentor mentee. Like, oh, okay, I've got to mentor this person. Oh, I don't have time to do that. This is a drain on my productivity. Whereas the mob programming concept doesn't have that dependency. It's not like, well, I've got to help this. It's more of a group situation. People seem to be more open to it and more accepting of it because it doesn't put a load on one person.
Yeah.
It puts the responsibility on everybody, and usually people are eager to get together and solve these problems. So setting up a mob even between the three tracks was not. It took some time to set up at first, but people were typically open to it. It was I think some of the project managers were initially sort of hesitant or didn't really quite understand it, but once they saw it work the first time, it started to gain some steam.
That's fantastic.
Yeah, one yes and a follow-up question is, what's funny is this is like the first show where we're explicitly talking about embedded systems or firmware, but Chris and I have, both of us, many years of experience of mobbing and software programming, where we're interacting with hardware and firmware and interacting with those engineers. And it's just funny we haven't talked about it a year in, and here we are, we're finally talking about it. Yeah, so I mean, one thing that jumps out to me is that maybe as a follow-up question is, in my experience, getting software developers to mob, just in the context I've been in, has been easier, right? And that the firmware engineers joining the mob has been more intermittent. Like, for example, just yesterday, we were troubleshooting an issue, and we were pretty much mobbing with the firmware engineer for about an hour and a half. So he kind of joined our mob, and then he left, kind of thing. In these case studies you've seen, are the mobs usually like of one stack, like all software or all firmware, or are they sometimes mixed? And have you seen things that have led to one way or the other happening? Yeah. Right.
So they tend to be of one stack most of the time.
Okay.
There have been a few that have been mixed, but mostly of one stack. And when you talk about that interaction with the firmware developer, it kind of resonates with me because the software, and we can get into this when we talk about mid-agility, but the different tracks, whether it's software, firmware, or hardware, they tend to adapt Agile very differently. For example, software teams may have 2-week sprints, but firmware teams may have 30-day sprints. They may have longer sprints. The products they develop tend to be more encapsulated. Their products tend to be, they have longer cycle times or development times because they're tied to the hardware. And so they typically don't move as fast as the software teams. So that could be, the result of some of what you saw in your experience there, why, the firmware engineer was on for a while and then dropped off. But they tend to move a little bit slower, and they tend to adopt Agile differently. Maybe they don't have a daily stand-up. Maybe they have a stand-up once a week, that kind of thing. And that's proven to be more companies that have adapted Agile in that way, instead of saying, okay, the firmware teams have to do everything the way the software team does it with daily stand-ups and 2-week sprints. Well, it doesn't really quite work for them in most situations. And so you have to adapt it and change it to fit their needs. And if you do that, then it's going to work a lot better.
Yeah. And so you said earlier that the periodic mixed mobs or whatever, you said you threw out a number of like once a week or something along those lines. So I guess a follow-up to Austin's question is, when you have that periodic mixed mob, is it just like whoever has a dependency need can kind of call a mob together of the right people and start working on it? What's the dynamic there when you're getting these interdependencies together?
Right. Well, I think it's a good idea to try and establish a cadence, to try and establish a regular meeting at some point during the week, because obviously you're going to have urgent things that come up, but you don't want it to always be interrupt driven, because people are going to drop off, they're not going to show up, and if everybody doesn't show up or participate, then your results are going to be very limited. So you try and establish that cadence, that regular meeting, whether it's once every 2 or 3 days or once a week. And then most of the time, if you do that and establish that, people will show up and participate regularly. And then those issues that do come up, maybe they can wait until the next mob meeting if they can. And if it comes to be kind of a thing where you have, maybe you need to have more often, meetings more often. But
yeah, you can turn it up or turn it down. Yeah. So that's really interesting. You mentioned earlier that the project managers were, saw it and were didn't understand it at first, and then grew to accept it. And so I just wanted to dig into that a little bit more. Is what was their impression, and I guess also just management's impression of everything, and how did it go over smoothly? What were some things that were done right, maybe things that didn't go so well, that sort of thing?
Right. I think some of the skepticism revolved around, is this going to slow us down? Is this going to, interrupt our productivity? Is this going to be kind of a time wasting type of situation? Those were some of the initial concerns, I think, because a lot of people, particularly guys on the firmware side of the house, so they hate meetings.
Yeah.
And complain incessantly about going to too many meetings all the time. And they typically have to go to a lot because they have to support the hardware teams, they have to support the software teams. And so, this natural aversion to more meetings. Yeah. Oh, we're creating another meeting. Oh God, but once that's where a lot of the initial resistance came from. But once they saw the results and saw how it started to resolve blockers quicker, and if the project managers are doing their job right, they're gathering metrics, and they can see, in our little graphs or whatever, that blockers are being fewer and further in between and being resolved quicker, and productivity is gradually getting better on all sides, whether it's the hardware, firmware, or the software guys. That takes a little bit of time to prove out, but usually the proof is in the pudding, so to speak. The proof is in the metrics eventually.
Yeah. And
the resistance is just, we just don't want more meetings, or more meetings are typically bad, but they're not always bad if they're productive. And if they have, a goal in mind to get something done. And plus, meetings that are led and managed by developers tend to be more productive anyway than meetings led and managed by project or product management.
Not to be opinionated or anything.
Yeah, and that's fascinating to me. I mean, we recently did some episodes on remote meetings and the difference between meetings and mobbing, but it's fascinating to me that it was perceived or presented as a meeting. And I think it starts out that way with a lot of people. Like I think of some people we've had on the show who started out with Mob Mondays. That's how they started out mobbing. And it appears on your calendar like a meeting, right? And so I have meeting aversion as well to a lot of things. And so I can see why that would be that would feel that way. But I think as I've seen with myself and others, as soon as they experience it, you're like, oh, this isn't a meeting where one person's talking and everyone's listening, or, you know, it's a discussion between 3 people with 10 people in the audience, right? It's this, we're actually getting stuff done. I'm contributing in the mob. Someone else is contributing. Someone else is saying something I don't understand, and we're getting stuff done, and the flow is happening, right? It starts to feel less like a typical corporate meeting.
Right.
Yes.
Yeah.
Yeah. So I think that kind of seconds what we hear from a lot of people is willingness to try and experiment is like the biggest hurdle, because once you try it, you can see what it's really like. So maybe this is a good transition to the next topic, and we can always go back and talk more mobbing, Chris, if you had more questions.
Yeah, that's great.
So I'm really fascinated about Agile and embedded systems development. So to give a little backstory to my question, I was previously with an organization that we did a from scratch Agile transformation. And it was from, it's fairly grassroots. It's pretty healthy, a lot of good things. There are a lot of things not done well, but we learned a lot in the process. There's a lot of team ownership and growth. And it seemed to do decently well in the software side of things for at least the times that I was there. And what happened was a lot of people on the firmware and hardware side were inspired. And there's one person in particular I'm thinking of who I'm still in contact with from this organization. And he's very inspired to adopt Agile or try Agile ways, but the firmware and hardware side of things are more waterfallish, right? And so I was wondering, from your case studies, your experiences, what have been some of the biggest challenges or biggest successes with Agile, mobbing, et cetera, in an embedded firmware type world?
Well, I think that, many companies, when they start down this path, they'll typically bring in consultants. And many of these consultants have worked only in a software environment. A few of them have worked in an embedded systems environment. And they try and do things the same way they've always done them, based on their own best practices they've learned over time, which is the hardware and the firmware teams need to adopt Agile in the same way that the software teams do, exactly the same. Everybody's got to do 2-week sprints. Everybody's got to have stand-ups every day. Everybody's got to do this and that. And the truth is that approach typically doesn't go over very well with embedded systems. And I saw that happen time and time again in the case studies that I worked with. And in many cases, consultants were fired, some of the directors were fired, and it resulted in a lot of people getting fired more than once because, they didn't change the way they were trying to adopt Agile to this specific context. And so I spent almost 10 years performing some case studies on trying to resolve this issue and find out how the successful companies were doing it. And what they did was they took a hybrid Agile approach. And hybrid agility has kind of a bad rap in this industry, because when people think of hybrid agility, they think of Wagile or Scrum or Fall, or they think of kind of a failed Agile transformation. Well, this is what you end up with when things don't go well. But the truth is, with embedded systems, if it's done purposefully, this is probably the best approach to use because firmware and hardware teams really don't need to adopt Agile in the same way in order for the entire company and the product itself to be Agile. And so, and at Agility, I talk about how these different tracks adopted agility differently. And the company also implemented certain techniques and methodologies for keeping these tracks in sync, so that the product was developed with the highest level of quality and produced on time. And one of those things was, for firmware teams, software teams may have 2-week sprints and daily stand-ups, but firmware teams may have 30-day sprints, and they may have maybe weekly stand-ups. And then your hardware teams may not have stand-ups or sprints per se. They may have more of a waterfall type of methodology to their development, but they're going to use techniques like rapid prototyping to be able to keep up with the other tracks. And we also had a process we called C-level projects, where we would, for $50,000 or less, the firmware team could develop a prototype or a specific piece of hardware that the other firmware or software teams needed to complete their work. And so we could kick off these little short-term projects that would allow the hardware teams to keep up with the rest of the company. And so this interplay between these different tracks and how that was managed was encapsulated in MetaGility. And this has been shown companies that were most successful with embedded systems that became number one in their market. They took on what I called a super agile adaptation. And what I tried to do in my framework was to encapsulate and capture that adaptation so that other companies could reproduce it and achieve the same results. Because these companies managed to become number one in their market, and it was largely due to how they were adopting Agile.
Is the so I think I relate to that. What is I guess I heard the rapid prototyping thing. How does rapid prototyping get introduced into an environment, and what does that look like, and how does it help? Because you said it kind of helps the transition happen when, you know, maybe the gears don't totally line up, right? And so I like that concept of rapid prototyping in order to kind of make it so that other systems that are dependent can operate more easily. So what does that look like?
Well, it was a technique used mostly by the hardware team. So for example, you know, the firmware team may need to develop a new version of firmware that also had to support whatever software was being developed. But in order for them to develop this new version of firmware, they had to have maybe a new version of the product with a new chipset, for example, that their firmware was tied to. And so, you know, the hardware teams may still be operating on a 12-month or longer cycle time. Well, we can't wait 12 months to get something to test against or develop against. And so the hardware teams would develop a rapid prototype using this new chipset, for example, that they could hand off to the firmware team so they could complete their work, and so that there wasn't that blocker there holding them all up. And so that's typically what it looked like. It was a tool used by the hardware teams to keep up with the rest of the organization and to keep things moving.
Yeah. So as long as there is a kind of maybe a value placed on flow, that's kind of what I'm hearing. If there's a value placed on flow, and the incentive is to maintain the flow through the organization, regardless of what the cycle time is at any layer, then having independent cycle times coexist is okay, because there's not as many blocks happening between the different aspects of the development. Would you say that's true?
Yeah, absolutely. I mean, it's really all that. Flow is such an important word. It's really all about flow. You know, probably the best metric to look at when you're trying to gauge the agility of our organization is a cumulative flow chart, where you can see, okay, where are the blockers in this organization, and where are the holdups? Where are the WIP, work in progress? Are we being held up anywhere? The cumulative flow chart allows you to visually see that happening, and it's all about flow. It's all about keeping things moving. That's so important to Agile. It really is.
Yeah.
Yeah. So one follow-up question, maybe it's a series of questions, because this topic fascinates me deeply. So there's a lot in the, you know, if we're saying Agile, my mind comes to Agile Manifesto, and there's a lot of values and principles in there. Some of them are continuous improvement related. Some of them are kind of, you know, what some might call management practices related, like, you know, release cycles and those kind of things. And then some of them are very technical. I think I heard one so far. So you're talking about some of the blockers to experimenting with Agile in a embedded type environment. And one of them seemed to be dependency on hardware, right? So you can't write code for hardware that doesn't exist. So is it that? And is there any other, what are the major blockers that make it not work for organizations?
Well, I think it's, the interdependencies, dependencies and interdependencies, which in the book I classify as two different things, meaning you may have one group may have a dependency on another, or you may have interdependencies where you have this complex interplay between all three of these tracks. I'm waiting on you, you're waiting on me, we're waiting on this person, and it gets kind of crazy. So I think the managing that interplay of interdependencies is a big part of what mid-agility is about, and how that ties to the Agile Manifesto. The Agile Manifesto tells us, well, it's people and interactions over processes and tools, right? It's one of the 4 tenets. Well, what are these interactions? What is that all about? We don't know. Does that just mean that mob programming is one of those interactions, right? But our studies showed that what I tried to do, especially within embedded systems context, is classify these interactions and find out what kind of interactions that the most successful companies were using and how they were managing those interactions and interdependencies. So, in the book, I classify those into 6 different groups, and I identify the different interactions under each group that our most successful case studies were doing and how they were managing it. And that proved out to be very important. Also the manifesto itself, when you look at those 4 tenets of the Agile Manifesto, which is what I know that they break it down into 12 principles, but I typically look at the 4 principles because that's what most people have in their minds when they think of Agile. And, it's actually, the research shows also that it's actually changed in terms of practice with respect to what the original manifesto stated. Like, for example, if you look at, what I just said, individuals and interactions over processes and tools, meaning that we're focused on our interactions and not necessarily on anything related to process or tools, but tools have become an integral part of making these interactions successful, right? And so that's how we've seen in research and case studies how that tenet of the Agile Manifesto has really changed over the past 20 years, because 20 years ago, or 19 years ago now, tools were very different than they are today. Today, you've got all these collaboration tools and tools that we're using right now to have this communication. And so tools actually facilitate interactions and processes. And so that aspect of the manifesto isn't entirely true today as it was back in that time. So in the book, I talk about how the Agile Manifesto itself in practice has really changed in how it's applied over the past 18 years, 19 years.
Yeah, I think you're right. If the tools are enabling the interactions to be priority, I suppose, right? But it's the tool is serving a greater purpose than the tool itself, right? So I guess one thing for me, just to, so I guess maybe my history and past makes me bent a little bit more towards the continuous improvement and technical aspects of Agile, because I just see a nice foothold there. So, for example, I am not an experienced firmware engineer, but I know a little bit about what's going on there. And so, for example, to have a daily build or to have continuous integration, how can you do that if you're dependent on hardware? Well, if you're following test-driven development and you have mocks, and I know a lot of, for example, I was seeing for IoT devices, they have a lot of these emulators where you can write code even without the hardware, right?
Right.
And so from that reason, it makes me wonder what the blockers are if these tools, as you're talking about, are available where you can say, hey, the hardware is not there or this piece is not there, but we can mock that out and we can run in our emulator and we can still run it through our pipeline and turn it off with the feature flag until the hardware shows up, right? So there seems to be footholds for kind of those technical practices, and then also kind of the continuous improvement. Like one thing I love about mobbing is we can be having kind of a continuous retrospective as the day goes, and that's one amazing thing that's in the principles from the Agile Manifesto is continuous retrospective. So from that regard, kind of from the continuous integration and from the continuous improvement, what are the blockers for firmware teams to faster cycles, so to speak?
Right. So, I think that when you talk about some of the emulator tools, that's certainly possible, and there certainly are, depending on the products you're developing and the industry you're in, there may or may not be emulator tools available. In some of the case studies that we worked with industrial IoT applications where there really weren't any good emulator tools available. You know, if you're working in an environment where you're building, you know, maybe applications for a cell phone, there's probably very good, or firmware for a cell phone, there's probably some very good emulators available, I'm sure. But in some of the more, I guess I would say, innovative areas where industrial IoT, we didn't have anything in some of the case studies I worked in. There wasn't. They had some emulator tools, but they were very poor. They really couldn't. They had no way of really simulating the IoT traffic from potentially millions of devices out in the field with the same kinds of environmental restrictions or lag times that you may experience in the field, you know, transmission lags and things like that. Just didn't have the tools, and if they didn't have the time to really develop the tools, they would develop some, but they were very limited in their capability, and so yeah, there were always and then in many industries as well. Many of them are tightly regulated, like, for example, power utilities or other industries where testing is extremely important, and there's a lot of oversight on testing, and there's a lot of regulatory compliance with respect to testing. So, for example, if I'm talking about a smart meter or smart grid industry, or maybe self-driving cars or things like that, where you know, somebody could get killed if there's a problem, or you know, my meter's catching on fire, or burning my house down, or my meter is charging me $50 more a month and cheating me out of money or whatever. So many of these, many embedded systems, you may have an embedded system that, you know, operates a flight system on an airplane, for example. Embedded systems tend to be in industries where there's a lot more regulation, where there's a much higher bar with respect to testing and quality. And where there's a much higher bar with respect to, well, I guess I pretty much said it, quality and testing, and a much higher bar with respect to regulatory compliance and a lot of government oversight. That tends to impact embedded systems a lot more than it does just pure software. And so in those situations, they really have to use the real thing to test against. For many reasons, and sometimes the emulators that they do have are just not quite good enough. At some point, it may be good enough to help do some initial development, but eventually at some point, whether it's a system test or right before release, they have to do a real test out in the field in most of those kinds of cases at some point. And if they can figure out ways to do that earlier rather than later, it's always better, because it'll be less expensive in the long run.
Yeah, the outer cycle times and the inner cycle times, and closing all of the cycle times to be smaller will help everything operate. But it's rare that you would see a lineup of the different cycle times at any one case, unless the teams are truly essentially one team and not maybe necessarily separate departments or something along those lines. So we also should kind of, it might be a good time to move on and ask, what is the Meta-Agility framework?
Okay, well, the Meta-Agility framework is a framework for Agile transformation and Agile implementation that has been, that focuses on your product development engine of your organization. They help you become number one in your market. That's essentially what it is. You know, there's a lot of competing frameworks out there. There's SAFe, there's LIST, ESDM. There's DA or DAD or Disciplined Agile, I think, that was recently purchased by PMI. So there's a lot of frameworks out there. Yeah. But these frameworks attack some of the same problems in different ways. You know, SAFe, for example, attacks agility from, you know, the 30,000 foot level at the enterprise level. Yeah. It focuses on, you know, making your HR departments agile and your legal department agile, and making sure your janitors have a scrum meeting every day before they clean the bathrooms. So it's about agilizing everything. And then you have Scrum, which is not really a framework. It's more of a methodology or a set of rituals, but it focuses at the team level. And then Kanban focuses at the process level. Then you have lots of frameworks that focus on things in between. But what Meta-Agility does is it focuses on your product development engine. You know, if you want to win the race, you want you want to have the biggest engine, you want to have the best transmission, the biggest tires. You don't worry so much about power windows and air conditioning. You want to win the race, right? Mm-hmm. And so what MetaGility does is it focuses on what it takes to become number one in the market, from your product management and marketing all the way down to your development teams and getting the product out the door to your clients. And many Agilists and frameworks focus a little bit more today on the social aspects of agility, like it's all about making our teams work better together and love each other and things like that, which is fine. There's nothing wrong with that. But at the end of the day, Agile is about competition. It's about becoming number one in your market. That's, Agile is a derivative of lean manufacturing, which came largely out of the Toyota production system and the paper that was produced in 1979 by those Toyota researchers that made Toyota, took them from making tin can cars to becoming the premier automaker in the world, basically. And so the whole idea is, the Agile Manifesto adapted those ideas to the software development industry. And the whole idea is to try and achieve the same kind of results that Toyota achieved. And so I think many of these frameworks have kind of lost focus on that, in my opinion. And so MetaGility was a way to kind of bring that back in, and also to focus on some of the contexts that have been ignored and not really well explored today, like embedded systems. I would argue that today, most innovation happening today is with devices, not with software alone. Yeah. And when you think about smart device, smart everything, right? Smart cars, smart meters, and so that embedded systems context is very important. And MetaGility cracks the nut of how to adapt Agile in that type of situation.
Yeah. So what is maybe a key difference in, I guess when bringing agility to a company, what is a key difference that we might see when we're relating it more towards the product over maybe other aspects of it? But I guess what would be evident in the strategy for this framework over others?
Well, one of the first things that I have in the book that we talk about is determining what type of Agile approach you should take, given your company and the kind of products you're developing. There's a researcher named Barlow who wrote an entire paper on how to determine whether you should take a pure Agile approach or a hybrid Agile approach, or just stick with waterfall depending on your situation, and go through a decision process on how to figure that out. And that was research. That's in the business research, one of the business research journals. And something I talk about in the book is it's a function of your team size, and it's a function of the complexity of your interdependencies. And I take readers through the process of trying to figure out which of those three approaches you want to take, given the kind of products you're developing and the kind of context that you're in. And I think that's very important, because many people think, well, you just need to go pure Agile, no matter what, or you need to maybe just to stick with waterfall. Well, or maybe we should make that decision based on some other. I think a lot of people are not aware that there is actually scientific research-based criteria to make that decision. Okay. And they make that decision based on, I guess, intuition or best practices based on a limited set of experiences.
How would the experience differ in the same respect to the product for software developers or firmware engineers or anybody kind of like at lower levels of the organization?
I would say that you mean how it's. I would say that agility would be maybe adopted differently depending on the context and the product you're developing.
Yeah.
So I'm just trying to make sure I understand your question. So, like for example, the firmware teams may not have adapt Agile in the same way as we discussed earlier as the software team, and the company may manage them differently. So, for example, with embedded systems organizations, if there's a problem, if there's a failure, typically the software teams are used as an early strike force. They want to try and use software as a way to provide a quick, cost-effective solution to solving a problem. Even though they maybe could solve it with firmware or they could solve it with hardware, they want to try and solve it with software first, because that's going to be the quickest, response and the cheapest way to get it done. So, for example, when you look at like the Boeing 737 MAX problem that happened a few months ago, where those planes crashed, they basically, how did they fix it? Well, they uploaded a new software application. If you have a new late model vehicle, you take it to the dealer to get your oil changed. The first thing they do is they check for software updates. Because that's how they're being managed. Most embedded systems organizations try to use their software teams to be the early strike force and to solve most problems with the software first, because a firmware or a hardware solution is going to be more expensive and take longer to put out there.
So maybe prioritization decisions would be made differently based on the product's impression on customers, rather than necessarily where the best technical place is to solve the problem, based on things like cycle times and things along those lines, and that shows up in the MetaAgility framework in some way, right?
That's right. Yes.
Okay. All right, great.
Yeah, one thing I really like about what you said there was, I think a lot of the frameworks, and I'm not certified in many of them, so maybe this is a layman's statement, but it feels like a lot of the frameworks kind of have like a big honking, here we go, you're going to take this, here it comes, and and I like what you said about you inspect, and figure out what the problems are, what are the good things, to turn up, what are the problems, and what's our next experiment, right? And that, to me, that's what comes down to the heart of the Agile mindset is inspect, adapt, experiment, right? And it first involves inspect, right? You can't buy a framework for a solution when you don't even know what the problem is, right? And so I like that idea to evaluate any change you're going to take first before you do it. I mean, how does your framework guide someone into doing that, I suppose, to figure out for themselves what's their next best experiment or next best move?
Well, I think it's important to take it one team at a time, one project at a time, and one program at a time. I think that's the biggest mistake people make is they try to push Agile across the entire company all at once, and that's the biggest mistake you can make. You need to start off, just start with one project or with one team, and then once that project goes well, then expand it across the program with multiple projects under that program, and then move it from that program to the next program, depending on how many product lines you have in the company or whatnot. But it's important to start off small and slowly grow it, and use that as use the success of that project, which hopefully it would be successful, as a test case. If it's not successful, maybe you need to do something differently. Maybe, we need to adopt Agile differently. Maybe there's something we did wrong, but at least you can use that as a way to fix it before you try and spread it across the company. Otherwise you're going to be spreading a disease and not not success. Yeah. So that's very important.
Yeah. You try to boil the ocean and you might be successful. You might make everyone too hot.
Yeah. Yeah, exactly.
Okay, cool. Well, this might be a good time to transition here. So we've talked about mob programming with embedded, Agile and embedded, MetaAgility. Is there anything you would like to end with or plug before we close out the show? And it's been a lot of fun discussing with you. I've learned a ton, so this has been great. But yeah, anything you'd like to end with?
Well, I would like to invite people to check out the book, MetaAgility, Managing Agile Development for Competitive Advantage. It's available everywhere, including Amazon and Barnes & Noble. You can type in MetaAgility on Google. You'll see all sorts of ways to purchase it. It's electronic as well as a hardcover copy. I also am teaching a set of courses based on the book. And you can go to metaagility.technology and pull up the current course schedule. Of course, those are originally designed as face-to-face courses. Those have all been, of course, as you can imagine, pushed back until the fall. So there's the first one's in August through November. Right. Hopefully, I'll still be able to have those. We may end up going virtual before it's over with, so we'll see. But those are still on the schedule, so I would invite people to check those out and check out the book as well.
All right, fantastic. Well, so to all of our viewers out there, if you feel like this episode would be helpful to somebody that you know, I encourage you to share it to them. I think that a good thing to do is to spread these ideas and just make sure that the people that can benefit from this material the most can get their hands on it. And I'd like to thank you, David, for being on the show with us. And to all our viewers, please like and subscribe, and we'll see you next time. Bye, everybody.
See ya.
Thank you.